They're available for anyone to use. We have weekly training sessions on those, and you can find out more if you go to the Gerstein homepage and click on 3D printing. We also have a virtual reality studio here, and you're also welcome to sign up to use that. If you don't have a project for virtual reality that you're working on, you just want to try out the HTC Vive, we have a bunch of apps and games loaded on there, and it's kind of fun to bring maybe some friends. Friday afternoon, come in and try the VR system. It's free. And again, you can find it on the Gerstein homepage. Just click on the virtual reality link and you'll find out more about that there. And if you ever have any questions about mobile software development, if you're just getting started or want to know where to look, or maybe you're working on a project and would like some assistance or support with that, maybe like trying to figure out how to distribute it or get it on the App Store, I'm also a resource at U of T that you can talk to for support on that stuff. So yeah, and SQLite. Why am I interested in SQLite, actually? I've been eager to kind of do a presentation like this recently because I've been using SQLite. It turns out SQLite is built into mobile platforms, and it's a great way to store data on them for apps. So I use SQLite embedded into apps to store data. And that's kind of how I got into doing the full text search thing, because once you have a bunch of data in your app, you don't want to scroll through all of it to find it. You want to just maybe search for it, right? So this is how that can be implemented. We'll go through some of the basics of how that works today. So I'm going to start with a brief intro about SQLite in case you've never used it or maybe need a bit of a refresher on what it is and how it kind of works. Just sort of the theory of it, I guess. And then I'm going to use Python to kind of dig into it and try some stuff out. So we'll do some live coding today. Feel free to follow along if you can. We'll try to go slow so that everyone can get it working. We'll do just some basic SQLite stuff, and then I'll get into the actual full text search module so you can see how that works and play around with it. Hopefully at the end you'll have something you can kind of mess around with and get to know. I just think it's really cool. I don't have like gigabytes of documents that I need to search at this point in my life, but I think it's still kind of cool to play with. But definitely it can scale pretty well, it seems, to larger sets of documents in case you want to get into that. The first question is, what is SQLite? What is it? So just in a nutshell, it is a simple, free, local, file-based database framework. So simple in that it's, I guess simple could be interpreted in a lot of ways. The way I interpret it is that it's just a very small framework. It's not a huge thing that you have to install on a server somewhere, like you might install Oracle. It's free, right? You don't have to pay a license fee to use it. It's really everywhere, actually, as well. So it's on mobile platforms. It's on your Mac already. You may not even have to install it. It's included in Python. It has bindings for lots of different programming languages. So you can use it directly from a C program or from Python or from Swift or lots of different languages. File-based also kind of goes with the simplicity of it. A lot of database systems that you might connect to, if it's like Microsoft SQL database or Oracle or SQL Server. A lot of these databases run on a server, and you need like connection strings and user accounts and access control, and you need to set up you have a server on a network that you have to maintain, and it's kind of complex. Or if you're using it on your own laptop, you have a separate process that you have to run in the background and manage as well, just to get it up and running. SQLite is basically embedded into your app or program or script that you're using. It doesn't exist as a separate process. It's just running. It's a sequence of commands or functions that you can call from your script, and it operates on a file that could be stored anywhere in a folder somewhere on your laptop. So it's really easy to set up. And it's a framework. So it's a series of functions that you can access. It's not like a network connection that you would be using to connect to SQLite. Why should you use it? So in general, why should you use a database, right? Instead of maybe just a file with a bunch of stuff in it, like or a bunch of values in it, or comma-separated values, or XML maybe, like those kinds of formats. Well, first of all, you might want to use it if you want to store persistent data. So this is data not just that you're processing in the moment. You want to maybe store the state of a data set and access it over many times. For me as an app developer, it's like maybe you're making notes or to-do items or other things. I would store those in the SQLite database so that you could retrieve them later. And then also why, this goes to why are you going to choose it over other more basic file formats? Well, for one, you might want to organize like lots of big sort of complex data sets. So if you have lots of different types of data that you're storing that are interrelated, for example, it helps you organize your data set and keep it up to date. And you may need to do complex searches on your data. So you may need to search and different related values from different parts of it, and SQLite has the language that allows you to do that. So before I get to the last point, for example, this is an app that I've worked on, and this is the user interface, right? So the idea of using SQLite, especially with full text search, is that you can start typing in the search bar at the top, and then it immediately brings up the results as you're typing. There's a couple things here. First, you want to bring up lots of options for people to select from that are relevant to your search. So you want to have a full text search that kind of is smart, right? It's not just very simple string matching. The second thing is that it has to be fast, right? So as you're typing, you want the search results to come up really quick, so it doesn't feel like the system is taking a long time to search for everything. People will use it more if it's fast. So SQLite is something that I've used, the full text search feature of it specifically to implement this kind of thing. So that's why I have used it. And then now, how actually is data stored in SQLite? So this is where I'm going to get into the basics of the structure of SQLite and how we start using it to store data. So this is just a conceptual overview. Apologies for the very basic graphics here. I put this together like in the last couple of days. The whole idea is that you have a file, right? Just one file on your disk, and then so for example, we're creating a database called the U of T Coders database, for example. Imagine we want to create a database for the U of T Coders Club to store information that they might want to keep around. So you have this file. It's represented by this blue rounded rectangle. And then inside of it, you can have multiple tables stored inside of it. A table is, rows and columns of information. You can have as many tables as you want, pretty much. And you would basically, each table could store one kind of object. So we have the talks table here, so that could be a list of like all the previous and upcoming presentations. Members could be the list of people in U of T Coders. Locations could be like places where U of T Coders have their meetings. And then sign-ins could be like if people were checking in and attending meetings, you could like record when they arrived, right? So you can even see that there may be some interrelations between these tables, because maybe for sign-ins might have a reference to which talk that occurred that it's recording, and which member signed in for which talk. So these kind of can be interrelated. In fact, that's why it's often called a relational database, because the tables have relationships. We're not going to get into the relationship stuff today because that gets a lot more complicated, but that's another kind of reason why you might use a database like SQLite to store your data, because you can codify those relationships. Digging down into the table level, so this is like you have multiple tables, and then within each table you have columns and rows. So this is the kind of basic structure that you define. So when you're setting up your database, you choose which columns you want to have per table or in a table, specific table that you're creating. And as you're adding data to it, you're going to add more and more rows. So each row would represent one particular object. So for example, each column you have the date, the title, and the maybe number of people who attended a specific talk, right? And then each row will have a specific set of values. So for today's talk, the first row, I have March 7, 2019. The title is SQLite full text search, and say 10 people are here. Maybe we'll include people who are online, because I'm not quite 10 people. And then the next row, we could have next week's session, right? And then so on and so on. So each row is kind of one combined set of data. When you're looking for stuff in SQLite, when you're searching for information, it'll return a list of rows that match your search. So if I search for, everything that had 10 or more people, it would return both of these rows, and I would look at them individually, and then maybe I could print it out so I could see, or I could sort it by from lowest to most to least attendance or something like that. SQLite doesn't really have like a built-in idea of like data or types, so you don't really have to like tell it what type of data is going to be in each row as you're setting up the table. But I mean, you can. It kind of ignores it. I just wanted to mention that in case it's just because it's one of the kind of weird things about SQLite that you may not be used to if you're used to using other database systems, because other systems are a lot more strict about what you can put into each column and row and stuff. SQLite is a little bit more simpler, I guess, is the simplicity of it, a little bit more forgiving, but it works pretty good. Okay, so this is a slide with some links. I'll put this up again at the end. I just wanted to let you know that there's lots of documentation. So there's a couple links to the full text search modules there, and then also to the Python integration module that I'm going to be using. Okay, so let's switch over and do some live coding now. I'm going to open up, I have a Jupyter notebook here, so I'm going to open that up to use. If you're using a Mac, another thing you can do is, if you don't want to do Python directly, you can actually run a command called SQLite 3. And you can put a file name, whatever you want to call it. And you can enter SQLite command directly into a database file. If you enter a file name that doesn't exist, it'll create a new file, or you can enter an existing one, and then you can search it and stuff. So this is really great because say you have a database with a bunch of information in it, and you're trying to debug it and figure out what's in it. You can always just load it up in the command line and directly interact with it without having to set up a Python script and all this stuff. So that's one nice thing about it as well. So it's going to quit here. But I'm going to be using Python today because it has a little bit of a nicer, kind of easier way to interact. And we're also going to be loading in some documents into it. So Python makes it easier just to load data into your what's it called? Into your database file. So let's say, okay. All right, so I'm just going to start with a new one. Is it too small? Okay. Let's see here. That good? Okay. All right, maybe I'm going to have to sit down because we're getting intense coding happening here. The great thing about SQLite, the wonderful thing that you're going to experience in a few minutes is that now we're not just using Python, but we're also doing SQL language at the same time. So we're doing two programming languages. It's not the greatest, but at least the code you write for the database side of it will be portable, right? So you can use it in with other systems, other languages. So you're separating how you organize your data from how you're accessing it with Python. So at least the data and your queries and your your table definitions and things will be independent of the Python implementation. So that's nice. Anyway, so to use SQLite in Python, we have to import the SQLite 3 library. That should be included in any Python installation. So let's see here. So you can just import SQLite 3. I'm going to import a couple other libraries just for our use today. And then this is just these two are just to help us load files into SQLite when we start doing the full text search. Let's see here. All right. So I'm not a Python person, so I tried to keep this super basic. if I'm not doing like the most efficient, best Python, I do apologize. And please just yell out if you see me doing something totally wrong. I'm doing it enough so that I can show some stuff on the screen. Normally, I would do this in Swift or Objective-C or something like that. But Python is equally good for working with SQLite. OK. So the first thing I'm going to show you is how to actually open a database file. So we have to create a connection. And we can create that using the SQLite 3 object. Let's see here. OK, so this connect thing takes one parameter. This connect, I guess, function takes, or constructor takes one parameter, and that's the name, the path to the file where you want your database to be stored. So, let's see here. Oh, and that should be a string. So I'll put right. String. OK, so this creates a file-based database. You can put it anywhere. You don't have to call it .db. You can call it anything you like, .SQLite. It's pretty arbitrary. If you want the alternative, I'm just going to show another option here that can be useful sometimes if you're just testing stuff out. You don't have to do it as a file. If you put in a special, that special command :memory : that creates an in-memory database. So it's not persistent. It's just in memory. But sometimes when you're just messing around, it's a little bit easier because when you recreate the SQLite 3 connection object, it starts up a whole brand new database. Whereas if you're working with this like a file-based database, from one session to the next, your changes are going to be persistent. So if you start adding a bunch of records and then you want to start over again and then you add the same records again, like we're probably going to do today, you'll have like twice as many records, right? Because they're all sticking in there. So just remember that. You can always do memory as well. So I'm just going to comment that out for now. And then we have to create a cursor object. The cursor object is the object that we use to interact with the SQLite database for most of the other commands. So we get that by going to using the cursor command. So, all right. We've created a connection and created a cursor. OK, so let's do some quick basics here just to see how to create a table and how to insert some values. This is like classic SQLite, not full text search, but it'll help us see what full text search gives us when we get to doing that. So we can execute SQLite commands by using the execute command. Let's see here, execute. And I'm going to enter a SQLite command here. OK, so now I'm just entering this command here. Just if we have to rerun this, we're starting over with a fresh table. Now we're going to create a new table here. OK. So this is really the important command here, create table U of T coders. So this is the name of the table. And then in brackets, we have a list of columns. Now, the order of the columns is kind of important because it remembers that order in the future. You can refer to columns often by name, or sometimes values will be returned in the specific order that the columns are created. I'm putting this one just before that. So if I rerun this command, it's not going to complain that that table already exists and give me an error. So it's always going to drop the table, which basically means it's going to delete the table and all of the data that's in the table. That's what the drop command does. But that means if I rerun this command, then it's going to let me just recreate the table. So for practicing and stuff, it's nice to be able to just start fresh every time you run that command. Like if I run this a couple times, right? So If I run it without dropping the table, you'll see that now every time I rerun this command, it says it already exists, right? We don't want to have that causing us issues. We'll just restart the table every time we need to test something new. Okay, so let's insert some data into this table. Again, we use the execute command. Let's see. This is a little, I'm going to make this a little smaller so maybe we can get that entire line on there. There we go. Oh, okay. Yeah. Make a new line here. There we go. Okay. There we go. That's better. Let me just make sure this one works, and then I'll add another one. Let's see. All right, let me just copy and paste this. We'll add a couple different lines. Change the values a little bit here. Let's say. All right. Okay, so we did that, no errors. Oh, I forgot we have to do a commit. Okay, so what's going on here? This is how you insert data into SQLite. Okay, so you have an insert command, you tell it the table you want to insert it into, and then you give it the values in the same order as the columns when you created the table originally. And then you add the values as an array in the second parameter for the execute command, and that matches up in order with these question marks, basically fills them in. This is a safe way to add data into a database. You notice that the first two here are strings. I can add strings directly in, but I can also add an integer. I haven't tested all the different data types that you can put in, but either way, you can add numbers or strings. Okay. So how do we get the data back out? Oh yeah, by the way, there's also this commit command. So this is really important if you're trying to persist your data to a file. You have to, in Python, use the commit command because that will basically make sure the data is actually written to the command. If you don't hit commit, then there's a way you can basically undo. So it's a method that you can undo stuff. If you close the database connection, it'll cancel everything since the last commit. So after you create a table or insert data, if you really are finished with that transaction, then you run the commit function, and it will make that permanent, make that a permanent change. All right, so let's get some data out of here. So we can use the select SQL function to get data out of the database. So let's see. So I've just done a select here. So this will look up anything that matches this kind of anywhere in the database where the date field has this value, for example. So I can specify which rows it will return. So I'm searching for every row that has the date value March 7, 2019. And then it will return that row and all the values in it. So if I make a change to this, for example, if I change it to March 8, right, it's not going to return any rows because there are no rows in the database that have that exact value. If I just include the first little bit of it, it's not going to return it because it has to be the exact value, right, that I'm typing in. Oops. Let's see here.
This is SQLite.
Sorry?
I think you switched to the whole cell. To
oh, yes, thank you. There we go. And then you'll also notice if it's case sensitive. So if I put March and sort of capitalized but with lowercase, then it won't find it either because when I inserted the data, it was capitalized. So this is how you would normally find data in SQL. You would search for it. It'd have to match up exactly. It wouldn't have any kind of fuzzy search. So this is kind of what we're going to use full text search to kind of get around. Another way to search that's a little bit more fuzzy, you can do a certain amount of pattern matching in this without doing full text search. And I'll show you how to do that. So let's actually just copy and paste now, since we're going to be doing mostly the same command here. So I'm just going to copy and paste. All right. So instead of doing date equals, I'm going to use the like operator. And that lets me use a pattern, and that lets me match something a little bit more, fuzzy in a fuzzy way. So I can use the % operator there, and let's try this. Okay, so now we're matching. Sorry, this is kind of low on the screen. Now we're matching. Just maybe make some more lines here. We can scroll up. Okay, so I've matched. You can see both records were returned here because I'm using the like operator instead of the equal sign. The like operator lets me do something called pattern matching. With pattern matching, you can put in a % symbol to kind of be like a wild card, right? So it'll match any row, any row with the column where the date starts with March, but it has anything else afterwards, right? So it matches March 7, 2019, and then it matches March 14, 2019. And it matches any row that has like just that prefix, for example. You can also put the % ahead of it. So if you want to match anything that's end with 2019, you can do that as well, and it will match the same ones because all of those both end with 2019. If I just say put 20, it's not going to match anything because there are no rows that end with 20, right? They all end with 2019. But if I put a % on both sides of it, it'll match something that has anything before 20, anything that has like the number 20 in it, basically, and it has a wild card for before and after. So it's just kind of like a wild card pattern matching search kind of thing you can do. But it's very precise and kind of brittle in a way. As you start playing with it, you'll find that it's hard to find certain combinations of things with this. It's hard to limit your search or to kind of evaluate which search results are more relevant than other ones, for example. It's like all or nothing. If you put that % sign there, it'll just match everything up until that point, then the word that you want. And then if there's another % sign, it'll just match everything after that. So it's a little bit rough in a way. So that's where we get into doing something like full text search, because it gives us a little bit more of a fuzzy kind of way of searching for terms. Okay, so I'm going to start doing full text search here. SQLite has, let's see here. I'm going to open the website here. So this is the SQLite homepage. I'm going to click on documentation and go down to extensions. So we're going to use FTS 4, the FTS 4 extension. SQLite has like a base library. This is like all the stuff that we've been using up until now has just been the basic SQLite stuff. But SQLite FTS 4 is an extension to SQLite. So it's like special functionality that's been added on over time. And there are two different types of full text search available in SQLite, FTS 3 and FTS 4. it's not like one is making the other obsolete. Like it's not like FTS4 has made FTS3 obsolete and you should never use FTS3. There are different reasons to use either one. We're going to use FTS4 today, but they have different trade-offs in terms of like performance and functionality. So FTS3 makes maybe smaller files, database files, but it's slower to retrieve stuff and it has less functionality. Whereas FTS4 makes like a larger database file once you import all your text into it, but it's maybe faster and has more stuff you can do like functions and things like that. So it's more flexible. So there are different trade-offs that you might want to decide to use one or the other. But I would recommend you start with FTS4 because that's probably going to be the one you want to use. All right, so FTS basically works like you create a table using the FTS engine, and then you add text into it using an insert command, and then you can search for text in it using a select command. It's just that there's a whole bunch of stuff that's happening behind the scenes that you're not really aware of, and there are a few special syntax things that are different with full text search. So let's get started with that. I'm going to create a new table here that we're going to use. So I'm going to do the drop table thing just to make sure we're not overwriting ourselves if we want to try stuff again. So let's see here. Okay, so this is how you create your table where you're going to store all your text that you want to be able to search using the full text search command. So instead of creating, create table, we're doing something a little bit different. We're creating something called a virtual table. There's nothing too magic about this virtual table thing. It's really just an interface to like SQLite. When you create a virtual table in SQLite, what it means is that you're creating a bunch of tables that has an interface as if it was one table. So you don't have to think about it as a bunch of tables. You think about it as one table. But SQLite handles all this kind of magic stuff underneath. That's what they mean by creating a virtual table. And now we, instead of just giving it a name, we're also giving it this command using, and then we're telling it that we want to use the FTS4 engine for this table to index all the text. And we're giving it the names of the columns that we want to have in the table. So what sort of types of text? You have multiple columns basically to keep your text organized. You can have a file name, and then you can have multiple text columns, and all these columns are going to be put into the full text index for each record. Okay. All right, so now we're going to insert some files into here. I'm going to type out, this is probably the longest section of Python to import, just because we have to import all the data. I'm going to be using text files that I got. Now, basically, you can use any text files you have. If you have a bunch of text files on your laptop and you want to just pop them into a folder for using, that's great. That would be good. The place that I got my text files was just from a website called textfiles.com, which is like a repository of like 1980s bulletin board system text files. The reason I chose this is I didn't have a lot of time to find text files. So if you just type text files, this is probably what comes up. Also, what's great about this is that they have a series of topics, text files separated by different topics. And if you go into a topic, there's a zip file that you can just download all the text files in like one zip file, which makes it easy for me to like put it into a folder here for importing and all that stuff. So, so what I did was just go to where are the files there, and I went to Science, and I downloaded all the files in Science. This is definitely like 1980s hacker BBS culture. So I would say not safe for work in most of these topics. Science seems to be okay, but yeah, just beware of what you get. It might be a little bit weird. So anyway, if you want to follow the results that I'm getting, then go to the science one and just click science.zip, and it will download all of the science files that we're going to use. Later on, we don't really have a lot of time today, so later on, if you want to get the actual database file that I created for this section, I can put it on USB stick for you. You can copy it as well, or I'll post it later as well. Okay, so let's go back to the notebook here, wherever I put it. All right, so let's insert all of these files. All right. I'm just going to create a variable with the location of those files. Where that was unzipped to. If you're using your own files, just make sure that there's only like text files in this folder, because we're just going to read everything that's in there. Now we're going to iterate through all the different files and load them and put them into SQLite. Okay, so hopefully, let's see here. All right. Hopefully no typos. Okay, so this is good. All right, so what happened here? This is just a bit of basic SQL to open up the file and read the text. The important thing here is that we're using the same insert command to insert the data, but this time instead of inserting it into the U of T coders table, we're inserting it into the files table that we created in that previous command where we created the virtual table. So we're inserting the text into the virtual table instead, but it's the same insert statement that you would do for any other table. You're just inserting values. It just happened to be inserting hundreds of text files into it. I've also catching some exceptions because in those 80s era BBS files are surprisingly not necessarily Unicode compliant. So often SQL on these particular files is going to not like them. So I'm just printing a message if there's any problem loading and inserting one of those files just below. So there's like 4 or 5 files here that it couldn't read. So that's just a good way to kind of check that everything was inserted properly and not have Python just give up once it reaches an error on one of these like hundreds of files. And then finally, we do a commit message. And the commit message will make sure that once they're inserted into the database, everything is persisted so that if you reopen the database later, you'll get the same data back. Okay, so with everything inserted there, well, we can do some queries and look for data in it. So do a basic search for one word here. So I'm use a for statement just to enumerate through the results. The execute command actually returns an enumerable object that you can use to like cycle through all the rows that get returned if there's more than one row, which is nice. So select statements. We're going to just return the file name column because we don't want to return all of the text because these text files are like hundreds of kilobytes. So we'd be returning, megabytes of data every time if we returned every single column, right? So we're just going to return the file name column so we can see what was found. Let's see here. Okay. You can search for the word relativity in this scientific corpus of the text files. All right. So I'm going to run this. OK, great. Wow, everything's working. This is awesome so far. All right. So now we're doing full text search. OK, so this is what we wanted to try. So this time, it's, again, a select statement. Same format as most other select statements you would use in SQL. We give a table name, sorry, we give a column name. So this is the column that we want to return to see, and give it the table name, and then give it a where clause. So we can select which particular records we want to see. But instead of using equals, right, or the like command, we're using the match operator. The match operator is a little bit different, but that's what gives us the full text search matching instead. What SQLite is going to do is it's going to search through its index. When you insert stuff, there's a whole bunch of things happening. So when I've inserted those text files, they're not stored as like just as like just the full text file. They're actually, SQLite will go through and break them up into individual tokens, right? So every word becomes a token. It's going to parse it and eliminate all the white space and put each token into another table and index it separately. So it can really quickly look for a word somewhere in your big text file and be able to find that in a table that's sort of got every word kind of separated out individually. When we were doing the like match previously, just the regular select thing, SQLite had to go through every row in that table, look at the column that we're kind of matching, and then look through the text in that column and see if it matches that pattern that we put in for the like. And it's got to do that for every row, every time you do that search. It was pretty fast when we did that with 2 records, but if you have 10,000 records or 1,000,000 records, it's going to be super slow, right? But with this, it's got a really quick index. It can just jump to the word that you're looking for, and then it'll have a reference to the document that it was stored in and the location of that word in the document, and it'll find it right away for you. So that's what it did here. It found all of the documents that contain the word relativity, and it gave us the result. That's just a basic search, okay? We're going to use this as a template and try. I'll show you some different things that you can do with this. It's a little bit more complicated. So let's copy and paste that. Put that in here. We're going to change this a little bit. We can search for multiple terms. Let's see here. So if I just put a space and then add another term here, now this will search for all the documents that have both the word relativity and the word special. So if you put a space and then you have another term or space, you can do this multiple times. You can have 3 or 4. It's just basically an implicit and operator. So it'll only return documents that have either relativity, or sorry, have both relativity both relativity and special in the document. Let's see here. You can do or as well if you want. So I'm just going to go and paste in here. We'll try that. To do or in your search term, you just put capital case or. It can't be lowercase or. It has to be capital case or. And now it's going to find documents that have either relativity or special in it. And it's going to return all the file names for that. You can also search for a phrase. Now, let's see here. Oops. if I wanted to search for literally like special relativity, right? Because what I was searching it for before, it was like if special and relativity are in the document, they don't have to be together, right? They could be anywhere in the document. As long as it has just those two, exactly those two terms, then it will return it. But if we want special as a specific phrase, then you can put it inside double quotes, and then it will only find the ones that have literally special relativity, okay? You can use a minus sign. That's like not. So this is returning all the documents that have relativity and not special. So it'll return all the documents that have relativity, but not the word special. Again, doesn't really matter where they are in the document, as long as the document has those terms, the term relativity somewhere in it, but nowhere does it have the word special, then it will return those, it'll be selected and returned. There's another one here that you can do that's a little bit more picky. It's called near. So if I put the word near instead of or and or the minus sign, I put near. What's going to happen is it's going to return documents where special and relativity are near to each other within a certain number of terms. So I think by default it's like if they're within 10 words of each other in any document, it'll return that document as a result, which is useful. You can customize that there. If you go into the documentation, you can specify exactly how near they have to be to each other. But the default is about 10, which is a good default. Okay. You can also tell it which exact column you want it to search in. So right now, we have two columns in our database, right? We have the file name column and we have the text column, right? We have the file name column because we want to basically be able to track back to which file had that document in it later on if we get a result. But it turns out that it's actually indexing both columns. They're in separate indexes, but when you do a full text search, it'll search all the columns for the word that you want and then return it regardless of which column that it finds. If you want to, have it only return a result if a specific column has that data, you can specify that in your search. So you can do, let's say, if you want to search for a file, specifically just the file name that has the word FAQ in it, and I can put the name of the column I want to search, a colon, and then FAQ, right? You could also, put, let's say, select file name from files where file name match, and that would also specify the column you want to search. But this might be useful if you have like user entered data and you want to allow the user to select which column they want to search, like in your mail program, if you want to search for title or subject or body, right? The user in this case could interactively enter a column name. So that's something that you can do depending on how you want people to interact with your database. Okay. So now we're just returning file names, but what if we want to see some context for where it's finding those terms? We can use a function called the Snippet Function, and that will return a snippet, a section of text near where it found the actual result. So I can add that here. Instead of selecting the file name, I can use the Snippet Function. A long statement, so I don't know if I can break it up. Actually, probably can because we have string matching here. Okay. See if this works. It might not work. Okay, yeah, it does work. Okay. So it's a little bit messy, so I'm just going to print something in between the records so that we can see how it looks. All right, so in this one, I'm searching for every document that has both the word relativity and the word special in it. And in this case, it's actually returning a little bit of the text. It's finding a bit of the text with both terms in it. And it's also highlighting it with these kind of begin and end things that I put in here, so I can see where the text was found easily in the snippet. And I'm also printing out the, let's see, the file name here, so we can see which file, where it was found. I'm doing this by using the snippet function here. The parameters to the snippet function are the following. So the first parameter is the name of the table that you're searching, which is that file's virtual table that we created. The second parameter is whatever text you want to put. Basically, it's going to wrap each term that it found in these two symbols that you put in here. So I just put these kind of greater than and less than signs just to make it really obvious where it's highlighting the text. It's arbitrary though. You can put whatever symbol you want. A really useful one is to just use, for example, HTML tags. And say you're printing this out somewhere, you can actually make the results bolded, right, where it found the actual results, and it will return it already pre-formatted for you. The fourth parameter here is the ellipsis characters that you want. So this is just where it's going to insert the beginning and ending ellipsis in the results. So you could do like, if you wanted to. So again, it's just a way to kind of customize it, right? It's kind of fun. So the snippet is useful because when you're presenting the results to yourself or to a user or something, that gives them some context to evaluate whether the result is what they're looking for or not. Let's see. There's other information that you can get. I won't demonstrate it now. It's in the Jupyter notebook because we're just about to run out of time, and there's a couple of more important things I want to talk about just really quickly. You can also use an offset function. The offset function will return the actual numerical location in the document where the terms were found. So if you wanted to go back into those documents and look them up and kind of do some further processing on those terms, you can use the offset function to get that exact information. There's another function called match info, which returns a lot more kind of like statistics about the find. Basically, the number of matches in a particular document and other kinds of things you might use in a calculation of relevancy. So match info is a function that you can use to sort, get values that you might use to sort through or sort the data in some kind of order of relevancy. That's a whole other topic that once you get into full text search, this is like kind of like a deep dive, or it's a world within a world, right? The database world within a database world, because relevancy is also really important. You want, when somebody searches for something, you want them to like the first couple of results to be the most relevant results. So there's a lot of different theories and formulas you can use to determine that. But the match info function is what you would use to get that information out of the database from SQLite. And then there's also a way to directly access the full text index. So you can get things like the number of the number of occurrences in the entire database of a specific term. So if I wanted to know how many documents had the word relativity in it, or how many, let's see, how many times the particular term relativity occurred in the entire corpus of text, then I could do that as well. So that maybe you want to like extract information about a corpus of text to put into like a machine learning algorithm, and you need to know the frequency of words or what are the top 40 words in this particular type of document. That's another function you can use if you want to dig down into the documentation. Again, I have an example of that in the Jupyter notebook to look at. That's really cool. But one final thing I wanted to show you is quite important here, and it affects kind of how your thing works, or sorry, how your search results are given to you, and that's called the Tokenizer. So you'll notice, if I scroll down, you'll notice in these results that they're not case sensitive, right? So it's matching this relativity here, but it's also matching this one. So it's unlike the previous thing that we were, the previous like operator that we were using, or like clause. This is not case sensitive, which is really great in a lot of contexts. But there's actually a kind of even better thing that you can do to find more results, and that's by changing the tokenizer. The tokenizer is a function that runs on your text as you're inserting it into your database, and it sort of normalizes every word that you input, so that when you input text later on, like maybe capital letters, it'll normalize it into this kind of common kind of lowercase format. Might remove diacritics from or non-Latin characters and things like that, so that when you're typing in, maybe you're typing in a French word into Google and it'll return, but you don't put in the accent on the E or something like that, but you still get the right result. Google is basically normalizing your search terms in the text so that they can match regardless of these kind of sort of arbitrary factors. So SQLite can do something similar to that by through its tokenizer, and you can customize which tokenizer it uses. The default one is called the simple tokenizer, and all it really does is just remove certain ASCII characters or kind of punctuation things that don't matter. It'll ignore those, and it'll make everything lowercase, so it'll match things regardless of the case. The index is going to be all lowercase words. So you can change it. We're going to try one called the Porter, a stemming algorithm, which does a little bit more sophisticated transformations on text. What this will do is it'll do something called word stemming. What this means in English is that, say you have a word like relativity, and you also have a word like relative, and then relatives. It'll basically cut that word down into its root, just relative, without any kind of suffix on the end, so that if you're searching for relativity, it'll return relative and relatives and relativities and a lot of similar words. So when you're inserting the text into the database, it does the stemming function, then it inserts the stemmed word, the sort of smaller version of the word, into the index. Later on, when you're searching for a word, it'll take each of the terms that you input and then also do the same transformation on them and reduce them to like the smallest common denominator. And then it'll match that with the index. So you're kind of reducing everything down into like the smallest common denominator before it finds it. We can enable the tokenizer here by putting in a special parameter way back up in line 23 here, where we created the table. So this is something you would only do when you're actually creating the table. You can't change it later. So you have to decide when you're starting out what you want to do. Let's see, tokenize. Okay, so we just add comma, tokenize equals Porter, and that will change the tokenizer. So if I run this line, it's going to delete the original table that I created, so I have to reload all the text files here. Okay. All right, now let's scroll down to where we were getting those snippets and see if we get some different search results here. Right, so here, now it's finding relatively, right? Now it's finding relatives. So it's a little bit more fuzzier, right? This is something you really couldn't really do with the basic search or like matching or maybe even regular expressions, maybe without a lot of custom coding and stuff and messing around to try and emulate it. But if you use the Porter stemming algorithm here, you get that included with the full text search, and it's really powerful. With the sort of one thing is that it's English only. So if you wanted to do it for a different language, you could create your own custom stemming algorithm, or maybe there's an open source project for a particular language that you want to use with this. There's also another stemming or tokenizer called Unicode 61. You would select that, just instead of putting Porter, you put in Unicode 61. Let's see if I scroll up here. So with this one, it's really more like the simple one, but it uses Unicode rules for making stuff lowercase, which is a bit more flexible. And I think it handles diacritics and other types of characters better. And there's also an international one that, again, will try to follow international particular language rules for lowercase letters and word boundaries and things like that. So word boundaries in Asian languages may be different than word boundaries in Latin languages, right? But again, the Porter one is probably the most powerful of all of them because it does that word stemming thing, which gives you more fuzzier results. But unfortunately, it's English only. So that's how far I wanted to get today. I just wanted to kind of show you how powerful the full text search here is. For me, it's especially important because I want to create a kind of search engine in an app that users can type stuff into and that it will kind of work just like Google works, right? It finds relevant results regardless of, you don't have to guess what exactly will get the result you want. It kind of guesses for you and gives you useful results based on that. You can also, if you use some of those functions, you can extract numerical information about a text, like the frequency or the number of terms in a search in a corpus as well, which could be useful for textual analysis, I think. And it's also fast and performs really well. So it's a really great kind of thing to use. And I think it's just really neat. And then once you get into it, you realize this is like a whole world because you think, wow, there's even more stuff I could get into, like how to sort the relevancy of things and that kind of stuff. So another great thing is that the documentation is very complete, very well documented. And I'll just show up this last slide here so you can get the link to that. And that will be it for me for today. I'm happy to answer any questions. Sorry, I went a little bit long today. So yeah. Great.
Great. Thanks so much. And we'll post these online to the website and we'll put it under the event.
Can I see your reception table on your Jupyter notebook?
Yeah, sure. I'll put that up for you here.